Okay, guys, how are you? And this video I can take you for a tutorial for the mini project report. So, as you remember, the mini project report, well, I'm going to open the canvas to show you what I'm talking about. So, if we go to the canvas, I need to sign in again. Just give me 1 second, please. Okay, just sign on the other page. Okay, so here we are. Okay, so in my canvas, if I going to go to the subject, and then we going to the assignments, you will find that we have assignment number. Sorry, it's not assignment. It's the mini project, not the fabrication or the testing of the vertical axis turbine. Is going to be this one, the study for all manufacturing. So click that. It's going to be due on the 7th. We still have 1 month to go through it, and you can just let me expand that. Okay, so I click on that. You will find the PDF file on what we need to do. So the long story short, I'm going to tell you actually what you need to do. You just get an artifact and try to make a study on how this artifact was made. All the parts, how they were made. So the key points you need to address, but not limited to: what is the artifact used for, how is the market, and how does it work, what main components will be focused on by yourself as a team of 2, what is the working environment, what service lifespan is going to be expected, what's the material properties are required, what are the materials may be selected to meet these requirements, what the dimensional tolerances and the surface integrity are required and critical, what the fabrication technology may be adopted, and what will be the workflow of the materials throughout a possible factory, and what is the material wastage and what may be the impact of the manufacturing processes on the environment, and what is the cost. Away from that, we don't actually need you to go too much regarding the design for manufacturing in this stage, but you can still talk about it. I will tell you what the design of manufacturing is. It's how to find alternative process to manufacture the same stuff with more efficient and less, for example, cost. Okay, so you need to do that as a group. As you remember, you need to have there should be a single page at the beginning of the written report to clarify and document each team member contribution for the individual marking. The personal reflection of 100 words minimum is going to be needed as well. Once again, we can find the marking criteria is available here below, and then you are going to be able to understand what we need to do in this report. Here I'm going to give you some example of the artifact that you can adopt by yourself. I will start with the chair, the office chair. So this is an example for the office chair that I just got from a random website on the internet. And you can see that we have the gas rose, the base, the cylindrical and gas lift, the seal, the lumbar support system, the backrest, the arm sets, and the head sets. So it's all numbers here. You can actually take a photo of that and find the same thing. So let's start, for example, with the casters. For the casters, you can find that we are going to have these wheels, which are made of plastic. We can talk about how they were manufactured if you're going to focus on that. But in real life scenario, these will be something we're going to buy. Okay, so the casters usually are going to be off-the-shelf item. You don't have to manufacture it. But if you would like to add a discussion on how these casters to be manufactured, it's going to be very simple. We're going to make 2 wheels, going to have shaft in the middle, we're going to have the support, the pin, and the support, and then we're going to assemble it. Simple. Okay, the wheels is going to have a fit press with the pin in the middle. the horizontal one, because we're going to have vertical one, which is going to be sit here by snap, and this one, these two wheels actually going to be fit press with the horizontal pin. Okay, the twin wheel is another design that doesn't have a wheel. Okay, now usually those are going to be made by the plastic injection molding. Most of the parts here are also made by the plastic injection molding, but the pin themselves is going to be done by the machining process. Okay, now that's another design. The glides, which the chair without the glides usually going to have glides made of the metal and the plastic. Glides are going to be a good option if you don't want to have your chair to roll around, and popular for the healthcare workplaces. The locking, the lockings here. Okay, so the locking casters control the movement of your office chair and can be fixed in a place to keep the feel still. Actually, no, I'm not going to talk about this one because this is a control system. The base, we can have different shapes of the base. Now that's something similar to the one we had in most of the labs at the UTS. So this chair is made of foam, and we have the leather on the top of it, which is not going to be, of course, a real leather. The other parts is going to have the board here and the piston, cylinder and the piston, which is going to be made by the extrusion process both, and this can be made by the rolling process. Okay, and we're going to have inside the seal, which is going to be made usually of rubber to have the gas cylinder operated. This part can be usually made by the casting, which can, if it's going to be aluminum, or the plastic injection molding if it's going to be made from plastic. Sometimes they have a plastic with internal reinforcement, which is something like the same process of the plastic injection molding, but they're going to have a preset ring inside the mold. Okay, the base here, as we mentioned, is going to be done of metal by the casting process. Because the shape is not going to be that complicated, we can do it with the mold casting. Okay, if it's going to be from aluminum, if it's going to be from the steel, we have to do it with the sand casting, then it's going to be machined. The architecture base, most of these stuff are made by the plastic injection molding. Okay, of course this will be a foam to the shape, then it's going to be covered with certain type of cloth. Once again, you can see that different shapes of the web can be made by the casting process or the plastic injection molding, depending on the material we are using. Most of them are going to be metal, so it should be done by the die casting process. Okay, cylinder gas left. As you know, we're going to have cylinder. It's going to have a piston within, and each one is going to be made by a different process. And the cylinder, usually, if you're going to see something like a welding on the side, it's going to be done by the rolling as a cylinder. Then it's going to be welded, and then we're going to put the top at the bottom is going to be welded disc, and we can also add the plastic cup at the end well, first it's going to be for the appearance, and also it's going to work as a valve. The seat was going to be made from the high quality foam for the maximum comfort. High density polyethylene model foam is going to be the best option you can have. Okay, the upholstery can be made from fabric, leather, elastic, or the combination of these materials. The waterfall edge seat, like those types, rounded front at the slope, as you can see here, and the slope downwarded, and models to user body. Actually, I'm not going to care about this stuff. These are only different designs, and it's only about the shape. The other stuff is going to be almost common. We don't know his head set here, and no arm for the chair, but the concept is going to be almost the same. Okay, the backrest is not available here. This is the backrest types. This is without the arm seat. The arms, if we're going to have them, mostly this one is going to be, just let me check the chair I'm sitting in. Yes, it's a plastic on, yeah, plastic and plastic, yep. So the handles can be a plastic, unless we're going to be able to go up and down, and thus we're going to need some sliding mechanism, which require to be a metal. The headset, if we have them, like this one, is going to be once again plastic injection molding, and we can use some of the foam and the fabric on the top of it. So something like that, you can find the same website and you can choose a different types of the seats and talk about the different technology of the parts made. You go to the lab. This is obviously metal, is a metal aluminium, okay, and you can actually go to the uni and check the different seats we have there, and you can use them as guidance for your design procedure. Now, what the other thing that I also found and decided to be one of the things we can have a discussion on, that's for internal combustion engine, two-stroke combustion engine. So you can see that actually if you can go to this website, I think the name is, yeah, it's temperature, obviously, okay, and look for the piston head and the full engine drawings for the internal combustion engine with two strokes. So let's have a look about the parts of this the combustion engine. So you can see that we are going to have casted, casting and machined. Okay, all the parts are going to be done by the sand casting. This will be done by the die casting. This will be machined from a bar. This is a bearing. This will be casted, forged, and machined bearings of the shelf item. This can be done by the die casting process or the forge casting process. Then we're going to have the trimming for the side. Okay, then machining from the inside. These are the most important part. All the other parts can be off the shelf item. So usually that's going to be made of the steel. Sometimes they make it out of aluminium. The body with the fins can be made from the sand casting process for the cast iron, and we can also make it out of the aluminium. And for the aluminium, we can modify the shape to be able to work with the die casting process. There are blocks made from the aluminium, and I think that you can see that in most of the motorcycles. For the flange part, once again, it can be made of the sand casting. For the cast iron, then machined, or we can make it out of the aluminium with the sand casting or the die casting. So I'll just give you different technologies for that. For the road, and for the crankshaft, they must be made of steel, because you're going to get high impact and it's impossible to actually use the aluminium for this procedure. Any 3D printing possibility to be used here? The answer is no. Okay, so once again, you can, yeah, that's aluminium, and this probably aluminium from the color. I can't see that this one is cast iron, but it's possible to be made of the cast iron. Yeah, it's nice actually to have a look about similar website. It said that the videos are private. I don't want to play these videos now, but you can have a look on it. If we can open that or download it, then you can see what are the names of the parts, and probably they will tell you what the materials of each part we have there. These are different types of chairs. I don't need that. Yeah. The other design we can have is going to be for the centrifugal pump. Now, I think that there's a more clear one. Okay, so that's a design for the centrifugal pump. So, of course, centrifugal pump is the type of the pump that can take you to a higher pressure. Well, that's mean usually the pump is going to be measured to the delta P, which is the pressure inlet minus the pressure outlet, and this will increase the velocity higher and having a certain amount of flow rate. So this diagram can show you what is the different parts of the centrifugal pump. I think this one is SimScale website, which is actually they are interested in doing the CFD for the different types of the pump, and we're not about that part. We're only interested about the manufacturing section. So we can see that we have the case, that's the casing, we have the impeller, and we are going to have the hub plate, where the impeller is going to be sitting. The plate and the hub plate is going to make the impeller. We have the rotating shaft, and here should be the motor. Actually, we are not going to worry about the motor because it can be off-the-shelf item. Sometimes they're using the gearboxes, and once again, we don't worry about that. No, actually, this is not the motor. It seems to be this is just a shaft. Okay, so once again, the usually casing is going to be done by the sand casting process because most of the cases are going to be made of the cast iron, unless we're going to use it at high temperatures, and in that case, it's going to be made of the stainless steel or the super alloys. Now, for the impeller, there are different ways to make the impeller. We can make it with the sheet metal working if it's not going to be working at very high pressures, okay, and not high temperatures. So, for example, you cannot use for the car, well, actually, I'm going to search for that. For the car water pump, usually you don't use a plate which made of aluminium, but there are plates which made of iron, steel, okay, and this is only going to be folding the sides to create the shape of the plate. This can be made by the casting process, die casting or the sand casting. Once again, depend on the material we're going to have for that. This can be done by machining the impeller, okay, because you can have a disc, then you start to do the milling process on it to have that shape. We come into the shaft. The shaft is always going to be made of steel, different geometries, different diameters, and different edges we have there because we are going to have seats for the bearings and seat for the other parts on it, like the rings and the gears if we need to have it, and the coupling, and we have at the end. So once again, the case, I haven't seen a case made of aluminum before. Any possibility to have additive manufacturing here? The answer is probably yes. If I'm going to use the, for example, the arc welding additive manufacturing process. I saw people making the impeller using the arc welding additive manufacturing process. So they just make the shape and start to machine it to have the final geometry. Now, what other example I have here? Once again, this is the engine block, and you can find actually where did I get this one from? It seems to be a PDF file. Oh, I got that for whole motorcycle thing. Yeah, too many products. Actually, take the website name. I think if you search for this document, you'll be able to find out the name of the website, but it's called the Aero Expo Online. Okay, I think that the rest of the document should have the names of the different parts. But once again, this is going to be done by the casting process. This will be casting process because they are aluminum. Obviously, they're going to be done by the die casting process. This is cast iron. It should be done by the sand casting process, casting forging, sand casting. This probably is going to be machined. This will be cutted from a plate, okay? And for the washers, it's going to be done by the blanking process. And for the bearings, it's going to be off-the-shelf item. This can be casted and machined, or sometimes they're just machined, but I think it's always going to be casted and machined. So that's what we have once again for the internal combustion engine. What do I have here? I have here the jack, okay, the hydraulic jack. And once again, you can find the different parts. I found that in the slideshare. Just write down in your research the hydraulic jack engineering drawings. Okay, so here they give you what the different part of the hydraulic jack. And once again, of course, you know what are the environment of the work, the number of the parts requirement in the market. Like for example, you can manufacture something between, usually this will be done by the patch manufacturing. You can manufacture something like in the range of 1,000 to 10,000 hydraulic jack per year. The different parts, the screw is going to be made by the machining process on the milling machine. Multiple parts are going to be done by the extrusion or the rolling process. The sand casted part for the base, and then of course going to be machined. This cylinder is going to be done by the sheet metal working by doing the DB drawing process. Then we're going to have the internal part inside where it's going to be welded at the end, because you can see it's going to have two walls with the cavity within to allow the hydraulic to run between them. Okay, so just need to go through the slides to understand what the names of the different parts and how they were made. If it's going to be a thin sheet like that, it's going to be done by the plate metal working. You can see that the block is going to be made by the casting. Usually it's going to be sand casting because it have these internal details which usually going to be provided by the sand casting process. Okay, and those parts are going to be done by bending different parts of the metals to have the final shape. I think there are also some available materials on the side that you can have a look at. The trolley jack. Okay, trolley jack can be another example. We can have a work on it, which is something like the simplest thing. Most of the parts here are going to be done by the shear cutting. I think that we explained the side plate of the sand casting process. Most of the parts are going to be pre-cutted and it's going to be joined together by welding process. And there are actually no other way to make the trolley jack except by doing the casting and the plate cutting by the shear cutting operation. I think from the UTS. No, actually, you can search for this one. It seems to be a very nice project. This is from the LinkedIn, so you can find this guy and you can read about his work, and you will learn a lot. That's another types of the. Another jack. I just got that to show you things. Well, this seems to be very nice. Yep. So this show you actually the different parts. So the cylinder and the screw posts. So you can see that we're going to have the internal and the external parts. Both are going to be done by the machining process. They're going to be joined together. This nut is going to be done by the casting, then machining. The sand casting, because it's made of the cast iron, and that is going to be machined on the turning machine. This part, usually this part is going to be done by the plate forming process. Okay, Then it's going to be pinned with the other one, which once again, this will be done from plate forming process. This is a cylinder, and these two parts are going to be welded together. The base is done by the casting process. You can tell from the property of the shape. Okay, can I zoom in? No. Okay, this cylinder is a pipe, steel, and then it's going to be machined on the turning machine. This part, of course, after the casting is going to be worked on, usually on the milling machine. This main body is going to be just a plate that's going to be rolled to have that shape, then it's going to be welded on the side. Let's see if we have another design. I think this one is also have a look with. It's made of aluminium. That's very rare. Anyway, so you can see that this will be steel. This will be a steel disc, which is casted. Then it's going to be machined. Or maybe this is cast iron, but it's painted like that. Maybe it's just painted silver. Okay, this will be casted and machined. This cylinder is going to be a hardened bar, which is going to be machined to the dimension. Of course, all these dimensions are going to be critical because we have moving parts, so they should have very high tolerances in their manufacturing process. We have a thread here. We have this pipe is going to be done mainly by the rolling process. This part is going to be a plate forming process and welding from one side, and then we're going to have some punching to fit this pin with the main with the side cylinder here to keep the bumping effect like what we see on this side. This can be another project. The driller press, a mini driller press. Okay, and well, yeah, this is very nice shape. Actually, I hope we can make that as a project one day. Yeah, so it can tell you what the details on the parts we have there. Is it going to run with the computer? I don't think so. It doesn't work. Okay, so yep, you can look further about this project and see how the parts were made together, and you can write your report about it as well. This is more details about the base we have for the hydraulic jack. Okay, so what else do we have? There are many possible projects you can find here. Okay, the gearbox is actually going to be only made of shaft and gears. It's worth to look at. That's a carburetor. If you have an old car, not fuel injection, they used to have the carburetor before, which is just a place to mix between the air and the fuel. So it consists of multiple parts. You can search about the different parts, and you can see that the manufacturing maybe is going to be done by having once again the sheet metal working and also the casting and machining. Most of these blocks are made from aluminium. I think that I have another example here to show you that this is for the two-stroke engine, internal combustion engine. Most of the parts here are going to be casted individually, then they're going to be machined, and they're going to be assembled for with the other parts to have the complete carburetor. Okay, so as I told you, these are some of the examples that you can use it as an idea for your work. If you go to my YouTube channel, you can find an old video I made for the same topic, and this will help you a lot to make your thoughts about your report. Now, during this month, we're going to have a session tomorrow for the glass working, and after the session you can start asking me questions about the artifact you're going to choose, and we can go through the for further question for the rest of the semester. I'll try to find you some of the previous reports, and they're going to be shown actually during the session tomorrow. Okay, so I'm going to stop at this point and I'm going to talk to you further in the nearest chance.